Hi, this is Professor David Farina, and today's lecture we're going to be talking about Chapter 0, Charting the Heavens, and specifically Section 2, Earth's Orbital Motion. Now, the Earth's motion can be described in two main ways. The first of these ways is called the solar day. Now, a solar day has to do with the motion of the sun through our sky. But before we talk about that, we need to consider that what is causing our sun to move through the sky is not the sun itself in motion, but the Earth spinning or rotating on its axis. The Earth rotates on its axis each day, 24 hours. Actually, it's 23 hours and 56 minutes. But as the Earth rotates, the sun and all the stars in the sky appear to move. Now, if we were to take into consideration the rotation of the Earth, after one solar day, from noon to noon, when the sun gets to the highest point in its daytime sky, back to that highest point the next following day, that would be considered one solar day. Now, what's also something we need to take into account is the fact that as the Earth is moving around the sun in orbit, we also have an effect as well, as shown by our diagram here with letter B. So, compared to its original position, the sidereal day with respect to the stars is a slightly shorter time period than it would take to go all the way around to point back towards the sun again. As a result of this effect, the solar day is slightly longer than the sidereal day, and this has everything to do with Earth's motion. Now, what this does over the course of many, many months, over the course of a year, is it causes us to see different places, different constellations in our nighttime sky. But what it also does is it places the sun in a particular constellation, which we call the zodiac constellations, at a given point in the sun's year. And the Earth here, as you can see in the diagram in December, from our perspective, the sun in December would point or would be located in the part of the sky we would associate with Sagittarius and Capricornus. These are constellations that we would usually consider nighttime sky constellations in the month of June, 6 months later. On the other hand, if you were here in the month of March, the sun would appear to be in the constellation of Pisces. But in that same month of March, the nighttime sky, we would be seeing Virgo and Leo up in our night sky. So it's always 6 months opposite of what you would see in the night sky is what is the location of the sun in the daytime sky. Now, as the Earth goes around this path, which we call the ecliptic, what we end up having happen is the Earth and its axis are not at the exact same orientation as the path it moves around the sun. And if you've ever noticed, the globes are actually set up this way. Many globes at least are. And here with my globe, you'll notice that the axis of Earth, the North Pole or rotational axis of this globe, is tilted. And it's tilted at a very specific value. That value is 23.5 degrees from the to the celestial equator, which is the path of the Earth's equator, compared to the path of the ecliptic, its path around the sun. The result of this is that over the course of the year, Earth experiences a different amount of sunlight, which we call our seasons. And those different varying amounts of sunlight, for instance, the Earth's North Pole is tilted away from the sun in our northern hemisphere's winter. The southern hemisphere is, of course, in summertime at that opposite point in the orbit. And as we go around, the equinoxes are when an equal amount of light is shining on both hemispheres, both north and south. And when we get to our summertime, you'll notice the Earth's northern pole is tilted now toward the sun, causing us to have more sunlight. Now, not only are we going to have different amounts of sunlight, we're also going to have different amounts of energy or flux over a particular area during each season. So in the summertime, the sun's light is coming more directly from above. And you may notice it on your skin. It actually feels hotter. That is actually the case. It's actually got more energy in each minute of exposure of sunlight. And in the wintertime, the sun rays are coming in from more of an angle and therefore being spread out and being less flux. Now, the word flux sounds kind of hard to understand, but all it means is the amount of energy over a particular square area over a particular amount of time. So usually we describe flux as some value of energy per unit area per second. Okay? So like joules per meters squared per second. Okay? Now, each of these points in the orbit are of very special importance. So there are two places where the Earth's energy is shining equally on the equator and on both hemispheres, and those are called the equinoxes. We have the vernal equinox in the spring, and we have the autumnal equinox in the autumn. And then, of course, we've got the summer solstice. That's when the sun is as high as it's going to reach into the northern hemisphere. And then the winter solstice, when it's as low as it's going to reach and all the way into the southern hemisphere. There's also some pretty important lines of latitude we are discussing here. Of course, both the equinoxes, the sun is shining directly on the equator. And during the summer solstice, the sun is shining on the Tropic of Cancer. And in the winter solstice, it's shining on the Tropic of Capricorn in the southern hemisphere. Also of note here is that the northern hemisphere, specifically the North Pole in our summertime, receives 24 hours of sunlight for 6 whole months straight. And during northern hemisphere summer, of course, it's southern hemisphere's winter, they receive 24 hours of darkness for 6 whole months at the South Pole. And vice versa here at the winter solstice. And then during the equinoxes, they receive an equal amount of light in both hemispheres, 12 hours in the northern hemisphere and 12 hours in the southern hemisphere, everywhere on Earth on that particular day. Now, Earth's orbital motion also does something called precession. And precession is kind of like a top. And a top, as you know, wobbles after a little while. So you get it going and it starts to wobble. And Earth does this same thing. And as the top, or Earth, starts to wobble, it starts to do this precession thing. Now, precession, for something like the Earth, takes a pretty long time. It takes 26,000 years to occur. Currently, if you look at our Earth's North Pole, it points towards what we now call Polaris, the North Star, the current pole star. And I'm going to draw your attention here to Polaris on this other diagram. If you look back to the time of the ancient Egyptians, their pole star was Thuban, about 3000 BC, and here's Thuban. So the the Earth's North Pole is tilting more and more and more in this direction towards Polaris, and right around the year 2100, we will be the closest to Polaris as our North Pole will ever get, and then slowly it will start to precess away from this towards Cephus, and then eventually towards Cygnus with the very bright star Deneb as one of our North Stars far into the future. Looking at the time scale here, 8,000 AD, 9,000, 10,000 AD will be the time for Deneb. And then we keep going. Vega in the constellation of Lyra, the Harp, is going to be the brightest of all of these North Stars, and that's just about 13,000, 12,000 years from now. And then eventually, after 26,000 years, we will return back towards Polaris being our North Star. Now, what is interesting is that Polaris is a pretty bright star, and it's really close to this line of precession. So, once again, the time for Earth to orbit around the Sun relative to these fixed stars is called a sidereal year. All right, so the sidereal year is kind of like the sidereal days combined together. And then the tropical year has also to do with this precession cycle. Tropical year following the seasons, whereas the sidereal year is following those constellations, this 13,000 years. July and August will actually be opposite of each other. So if we go back to that previous diagram, if you think about it, if we go to the tilt of the Earth's axis being important towards our seasons, the fact that Earth is precessing, in one case, it'll be towards the North Star Polaris, but 13,000 years from now, when Vega is our North Star, the seasons are going to be switched. And so that's what we mean by this tropical year, tropical seasons. And Orion, which is one of my favorite winter sky constellations, will actually be a summer sky constellation. So that's it for our part 2. I hope you enjoyed the video, and tune in for part 3. Thanks.